My name is Rushil Goradia, and I'm an engineer on the autonomy team here at Bedrock Robotics. Today, we're going to talk about Bedrock's journey from 0 to 1, from our founding to doing real work at a job site in a little over a year. We're going to cover the technical approach that we decided to take and all the learnings, challenges, and milestones that we had along the way. To do this, I'm joined by two of my amazing colleagues. I have Brad and Tom. Do y'all want to introduce yourselves?
Sure. My name's Brad Neuman. I'm one of the founding engineers here at Bedrock. I work on machine learning, robotics, planning, a little bit of everything.
Hi, my name is Tom Eliaz. I'm one of the founders of Bedrock Robotics. I oversee infrastructure and software at Bedrock.
Awesome. So, Tom, take us back to May 2024, founding of the company. What happened when everyone got together? How did things get started?
Yeah, so we all got together to kick off the company in an Airbnb, I think in Sonoma. Brad remembers this.
I was there, yeah.
And I think really a few really cool things happened. So we had about 10 people, 10 to 15 people at the Sonoma Airbnb, and we all kind of knew each other in different ways. Some folks knew each other because they worked together at different companies. Some people knew each other from other relationships. And what we did was we spent a lot of time together, first pulling together the social string. So everybody kind of knew everybody, met everybody, knew how they all knew each other, got to know a little bit about every single person. We all talked about the way that we saw kind of Bedrock Robotics evolving, the challenges that we saw, and how we would solve them in the areas that we had kind of the longest vision in. And so it let us really start the company with this really strong foundation of shared vision. We also talked about milestones that we wanted to achieve, and that really let us accelerate into the first 6 or so months of the company as one whole team. But it was really this awesome combination of bringing together this social group of people now into one awesome team, and it felt pretty great.
Yeah, it was 8 to 5 intense whiteboard session,
30-minute
30-minute break, then intense wine tasting and dinner and debates about the philosophical nature of the universe, and then do it all again. And it was really we put so much stuff on that whiteboard. I think, you look at that and you said, oh, no way can we get all this stuff done. And, for the most part, obviously we were wrong about a few things, but we really, I think, laid out a pretty awesome plan, had a great team, and it was a ton of fun.
Awesome. So, other than, I'm hoping, a few cases of wine, what did you take back from that trip, especially in terms of the technical approach that we wanted to go with?
Yeah, I think we had a really great mix of people that had a lot of experience in various parts of robotics. And so we got to kind of reimagine, what would a system look like today in 2024, it was at the time, starting from scratch where we don't have 10 years of legacy and we can take advantage of the latest trends and directions that we've noticed, things that are kind of just starting to work. And so in my part of the world, the biggest thing there was end-to-end learning for the behavior system. And so, traditionally you have a robotic system that has kind of split up into parts like sensor fusion, perception, planning kind of algorithm or multiple algorithms, and then controls at the end. And we'd seen over time, of course, perception, the part where you kind of see and understand the world, had been dominated more and more by machine learning, but kind of more advanced AI and machine learning techniques had kind of just started really showing promise on the kind of planning and behavior side of the problem. And so that was, I think, one of the biggest bets where we decided to really try that, jump in, kind of all in on that, but in a way that I think was very practical, because all of us were very motivated to kind of get products out the door, right? This wasn't an R&D lab. This was really a company full of people that wanted to ship and build and bring things into the world.
Awesome. So can you talk a little bit more about what that means for Bedrock? What end-to-end means for Bedrock? We're operating this heavy machinery excavators. So how exactly does this end-to-end architecture work?
Yeah. What are the ends, right? I think a lot of people like to use end-to-end as a buzzword. And it can be a little bit flexible. But I think the big bet was just to not decompose the system in too many ways, in any additional ways than was necessary, basically. And so I think, traditionally you would have these components that were very easy to introspect and understand, like where are the trucks detected? What is the height of the ground at this point? And you can kind of look at those and debug those. And then you have a large system, often with a lot of rules, like, well, if the dirt is this high, then tweak the trajectory like this. And you have this system like that. And so we decided to kind of subsume all of that with data and machine learning. And so what that looks like is you have some inputs where, you understand the basic structure of the hardware. So what signals is it giving you back? you do some integration on those signals to estimate things like the pose of the system. And then you take that information and the images and the sensor data, and you feed that directly into a giant black box ML model. And of course, there's stuff inside that black box that attends to different parts of it. So there's part that kind of looks at the images and so on. And then the output of that is like a trajectory or a set of controls for the excavator to follow. And as a result, you wind up kind of demonstrating behavior that looks like what the behavior you were trained on. So the big kind of unlock with this, and also a challenge, is that it means that it's driven entirely by data. So we collect a lot of data of human operators, expert operators, really doing the right thing, doing great things. And then given the kind of context of what they're doing, some kind of goal, some kind of information, and the scene that they're operating in, our model then learns to replicate that kind of behavior. So it basically replicates kind of the best human behavior that we can collect. And it tries to predict what that looks like and then execute that on the system.
Yeah, awesome. So speaking of data and this data-driven framework, Tom, can you talk about what does supporting this end-to-end system mean, especially from an infrastructure perspective?
Yeah, I think one of the kind of greatest parts about the beginning of Bedrock and still Bedrock today is this passion to kind of get to market and to impact the real world really quickly. And so for infrastructure, that meant kind of absorbing the methodology that we wanted to use for autonomy, this like end-to-end model, really like data first model, and trying to figure out how can infrastructure support that as quickly as possible in the early iterations of the company. We kind of knew that we could always build this giant castle of infrastructure where everything is perfectly managed, and everything gets is labeled and tracked, and all that is great. And you really need that kind of in the company at scale. But we wanted to focus on this motion that we called the ML loop, which is really how fast can we make it from data coming in to understanding what model to train, to actually training the model, to evaluating that model, simulating the model, getting it back out. So really building that flywheel of learning that is going to enable this like super fast autonomy action. And so for us, it meant first really decomposing the systems kind of in light of that focus and really doing most of the work to facilitate this speed of ML loop, and really being thoughtful about where we kind of overbuilt in the lower layers that would really accelerate us, but mostly focusing on kind of this tighter loop and knowing that we were kind of building a lot of stuff that we would have to come back to and then eventually scale out and cost manage and track better. I think that's was like a complicated maneuver, but one that like clearly was focused on kind of the priorities for the company and how to get that flywheel going. And so I think we got a lot of that benefit kind of in the first year. And I think now we're seeing the benefit of coming back and really building out the larger systems that allow us to do even more scaled training, more scaled simulation.
Yep, that makes sense. So we discussed, like, we decided to take this big bet on an end-to-end approach. By July, so 3-4 months after this decision was made, we had a working model and simulation. So can you talk a little bit about that? How did we get there? What was the model actually doing as in its like first life?
Sure, yeah. I think one of the challenges, or one of the things we worried about with the end-to-end approach was, well, is this thing just going to not work at all until we have 10,000 hours of data, and we don't even have an excavator yet, right? We're just 10 people in an Airbnb. Like, how do we get this thing off the ground? And so the answer to starting that out was doing it in simulation. And so we found, a way to set up a simulation where kind of the key part that I think you don't hear much about in robotic simulation is actually the ground terrain interaction. So, the ground is moving, it's changing, and the way in which it's changing, the force that it puts back on the excavator bucket, the way it kind of scoops up, like those things are really critical to have some understanding of in your simulation. So we found a kind of basic, given that simulation setup that could do that. And we were able to kind of control or script some actions that could do some basic digging in the simulation. And we were able to actually find that given just that setup, we were able to set up what actually became our core kind of ML model that we're still using many pieces of today, and train it on just like a very small number of examples. And then it was very limited in what it could do, but it was able to show kind of signs of life right away where it could repeat similar behavior like that in the end-to-end loop, and we could kind of debug the choice of algorithm and a lot of the integration points. And so I think by around July, like you were saying, we actually had our first kind of integrated signs of life in sim where we had, a controller, some estimation and an ML model that we were training, deploying, and this kind of the first few passes through that ML loop that Tom talked about. And we were able to kind of validate a lot of that and get it working in simulation.
And this is a good example of where our instinct as infrastructure folks really had to be curtailed, because normally we would want to, when we think about simulation, we think about scaled jobs, and we think about like submitting these jobs and running on lots of clusters and tracking them appropriately, putting all the guardrails. And actually, the most important thing was for us to get this simulation as close as possible to the engineers and as close as possible to the data, and kind of co-locate them on machines that they could use to really like do the tight iterative loop. And so that was just one example of where we had to think harder about, how can infrastructure support the ML loop today and then tomorrow and then like long-term and medium term.
Yeah, I think a lot of the magic sauce there is figuring out like what to really overinvest in and which parts to kind of do in a quick and not scalable way, but that gets you there quickly, right? And I think we see that at a lot of different kind of levels at the company, where I think that's been a big key to our success, where like, for example, we actually really overinvested or correctly invested, I think, but at the time it almost felt like overinvesting in some parts of like the data API layer. So like, how do you manage, okay, this data coming from this robot at this time range? And I think given the stage of company we are, I would have expected us to have like a bunch of S3 links or like a USB stick or something, right? And just kind of like it being the Wild West. But we actually built a really nice, actually the best API for that I've seen, honestly. And we did that very early on, and that same API is still serving us today at scale. So that one was an example where we really like invested early and it paid off. And then Tom was giving an example where it's like, okay, but for the training loop at first, which of course that the ML training needs to scale to these big clusters and all this, but first let's just get it down so it's really fast to do these early iterations. And the early iterations, it took maybe an hour or something like that to train. So it was really quick to test stuff. This was very early, not the full capacity and capability of the model, but it let us kind of get that flywheel going, which was awesome. Yeah.
I'm glad you think the data SDK bets were the right bets to make.
Yeah. We're not here to talk about the wrong bets.
Excellent.
But no, it's great. And I think especially everyone's backgrounds here helped as well, right? Like we've all done this before. We know what the pain points are. You know how to build it right from scratch now.
Yeah, I said at the beginning I want to make sure we make different mistakes this time than we've seen in the past.
That
and I
sounds right.
think we've done a good job.
Yeah, that sounds right.
Great, awesome. So we have something working in simulation. The next big milestone was the actual machine, right? At the same time, we had the hardware team bringing up the machine. I think it was by November or December that we had the model actually running on the machine. So can you talk about what, if anything, did you need to change? Did it just go directly? Was there any like, sim to real gap in going from to the actual robot?
Yeah, good question. So we did kind of pivot the focus a little bit as a very small, scrappy company. And so, I think October was when we first got the machine. And then by like the end of, or maybe September, we could purchase it. And then October, we got it to barely start moving at all. And then November, we were actually running the model on it. And so we were able to actually, I think the cool thing is we were able to use the same exact training loop, the same ML loop, and the same learning algorithms. We just used them with real data. We swapped in real data because another bet that we made early on, we kind of knew this was coming. And so even though we were doing things in sim, we didn't like tie deeply into the simulation. We treated what was happening in the sim, we logged that into a logging framework that was matching the same format that we would use on board. And that way the entire ML loop was agnostic to whether this was sim data or real data. And so we were able to just swap in the real data and train the same model, same hyperparameters, same architecture, deploy that on board. We did a bunch of work on how to actually make it run on the hardware on board, which was different. But that was kind of integration, like ML model integration work. The actual architecture worked out of the box. It was a little slow, it was a little janky, and it couldn't handle a lot of variation. And that let us really test the entire end-to-end system from the kind of lower level robotics system to the ML, to the data pipeline and logging and all of this. So we were able to get that up and off the ground pretty quickly. I think that was maybe one of the big surprises, actually. Pleasant surprises was that, I think there were some voices early on that were like, oh, let's just build the heuristic system without all this ML first so that we get something out there first. And we actually found that by doing it in this way where we could practice and debug and sim, and then as soon as we had the hardware, we could like drop the model on there. We actually got that kind of kickstarted us a lot faster than I think it would have otherwise.
Awesome. What was the model actually doing? Like, what was the first thing that you did on?
Yeah, so we started, I think, well, the very first thing was literally just one scoop, right? It was just touch the ground, right? Lift it up and drop the dirt. And, of course, we all celebrated, and it was like a 10th real speed or something like that. It was, we have a GIF of Clay, one of the guys, doing this little dance after it worked, which is still a fantastic reaction.
Yes.
But the first task, we kind of actually just cooked up a little toy task, right? Which was like, kind of like, what is the simplest thing an excavator could do that would really be digging? And so we kind of like, and I'll use the prop. We just was like, okay, we call it the crescent. You cut, and then you just dump, and then you turn, and you cut, and you dump, and then you turn. And so it just makes this kind of crescent-shaped trench. It's not really, it just kind of this crescent shape with like kind of a berm behind it, like a pile of dirt behind it. And it's not the most realistic task, but it was the simplest task. It was something we could get going really fast. We could collect a bunch of data at our site. And that was the one that we kind of rolled out first. I won't say it worked the first try. It wasn't that magic. But really within like a month of starting to try it, we actually had it running. And then by December of that year, we had it running like that, doing that kind of crescent setup pretty reliably. And that was when we were able to start testing it with more and more data. So one of the key unlocks was adding more data at that point. But we're still in the realm of like small tens of hours at that point, just to do that very simple task. That was able to get us kind of proof of concept of the full system on board, kind of running in a nice way.
Yeah, that's awesome. What were the office celebrations like when like you got it to work? Here's this beautiful crescent that we have in the ground.
You should talk about some of the office ones. I remember some from Slack that I'd love to talk about. Or maybe I could just dive into
Go
those.
for it, yeah.
I guess I remember a lot of Hibiki in the office as well.
Yeah, there was. Yes.
So, okay, that's fair. But we don't have to go into that. But I actually love kind of the Slack celebration culture that we have. I'm based in New York. And we have an office in New York, and then there's a lot of engineers and multiple execs here in California, and then there's a few folks like throughout the country. And so for us, having celebration channels in Slack and the culture where people post like the gifts and people post their accomplishments, and so we've got very specific like channels where we like encourage people and we like name them all these funny names, and we encourage people to really post like celebrations big and small. And so a lot of the celebration milestones, some of the big ones, but also the little ones along the way, all kind of get posted and celebrated together over Slack initially, and everybody can like really look at the video, look at what's happening, like cheer each other on. And then we have these all hands every 2 weeks, and we of course do like lots of celebrations during the all hands. And so I remember lots of good office celebrations, but I also really loved that we started to bring together kind of this culture of multiple offices and multiple people kind of around the country. And so that felt really good to me as well as we were celebrating kind of those first year milestones.
Yeah, that part of the culture I think is really important actually. And like, I think it's relatively easy to celebrate, the big win of like the state of the art ML model is doing something cool. But the amazing thing about these Slack channels is you can go on there and say like, I finally got the cross compilation working. Like the build is finally working on this obscure device, and like everyone will celebrate with you. And like those small wins, I think keeping the momentum going on those small wins.
I think a lot of us have the shared experience of pain at all those different
That's
altitudes.
right.
And so we celebrate all of those because we know we've been there.
Right.
Yeah, I remember, I think my first PR 3 or 4 months ago, I think I had like this simple refactor of some existing code, and it was celebrated like I had like helped achieve like the first like autonomous dig or something.
That was some massive code. I remember that. Yeah. You jumped in on a good problem.
Yeah, sure.
Cool. So we've shown that the model can accomplish a task. Now we want to find what's the right task for it to do. So, Tom, how do we go about deciding what's the first like actual job that we want the machine to do?
Yeah, so I think kind of the evolution of Bedrock attacks this problem in lots of different ways in a bunch of different phases. And so I think the first kind of big question we asked, actually before we even started the company, is what do we think it should focus on? What is the really big opportunity that we think we have? And then how do we narrow it down to something that we could achieve in a few years that can actually transform the market? And so we thought hard about heavy specialized equipment. We thought hard about kind of these earth moving phases of large construction, of civil construction, being like really perfect for the overall like multi-year journey which the company has many journeys after that as well. But then like zooming down for the task. So Brad mentioned how we did almost like imitation learning style. I don't want to like almost like imitation learning initially to figure out like a little bit of the can we automate the excavator? Figuring out a lot of the first task that we wanted to attack from a product perspective was a lot of talking to potential customers and doing lots of customer visits. And I distinctly remember visiting a like wonderful construction site on the side of the highway in El Paso, and really seeing like the perfect dig. When you see it, you're like, oh, the perfect combination of like long run tasks and excavators, and they're doing a lot of real work, and there's other machines involved, and they got to cut at angles, and they're going deep, and so you kind of like felt like, oh yeah, this really all came together. And so I think a lot of the really initial kind of questions of what should the first tasks be came from doing these deep visits with our customers and learning more and more about how they use the equipment, but also how they think about their projects and what would have the biggest impact. And so we spent a lot of time with customers, and that was our approach.
I have a funny story about that project, actually, if you'll indulge me briefly.
Yeah.
So there was another site we visited in Phoenix, and I flew out there and saw the site digging, expanding a road. And previously, I worked on autonomous trucking, and we had a depot in Phoenix, and we were giving demos very early on in that. And the biggest pain in the neck there was this construction project that was happening on the 202 that was shutting down lanes, and the system wasn't ready. Now, of course, they're much better at construction, but the system was not ready to handle that yet. And then I come here to Bedrock, and that is the project that one of our machines is collecting data on now. So it's a small world. I had this one intersection, Kyrene Street and 202 in Phoenix. This is burned into my brain. But yeah, I think again, this is like, for me, it's another theme of striking the balance, right? Yeah. Where if you focus too narrow, right? If you just go to like, all right, we're going to dig this one long trench, you can easily just hard code that thing, and you can probably get something that like maybe even a few people would pay for. Yeah. On the other hand, I think if you go to this like fully general, anything anyone could ever do with an excavator, and if it's not fully general, then bust, then I think you just risk toiling as a research lab for years and years and years. And so I think we've done a really good job finding this middle ground where we're data driven, we're solving problems with data where we can. We're thinking long term about what is the next task, the next machine, like how is this going to scale to all kind of heavy equipment. But we also have like very practical deployments along the way where these aren't like one-off demos, but they're actually getting some capability demonstrated where the system is very general, but we kind of limit it in terms of safety and how it's going to operate, so that we know it's kind of capable in this one region, like these kind of mass earth moving projects.
I mean, I think not surprisingly, we take the same approach when we think about infrastructure, about starting small, making some investments, and then as those were playing out, making the kind of the deeper infrastructure investments that we've done over the past year. And I think the same is true really in all parts of Bedrock. That's just kind of like in our DNA, is this strike the balance, right? Like get things working quickly to start the flywheel, figure out kind of the deeper architecture investments, and then fill them in as things go on so that you can scale on top of it, and so that you try to avoid kind of any big inflection points. And I think we kind of do that everywhere, and I think we kind of feel that pace as a company too.
Yep, that makes sense. How did the model generalize? So as we started adding new tasks, how much did we have to change? Can you talk about that?
Sure, yeah. I mean, I think slowly we definitely started to improve and replace a lot of the early code, right? There's a lot of very prototypey kind of hacky code. We got that a lot of cleaned up kind of as we were turning the flywheel, basically. So I think it's like maybe ship a thesis. Like it's the same model, but I don't know if any of the code is still the same. But the core algorithms actually are still the same. They worked. But we started to need to add new capabilities to the model. And so, for example, this early model where we were just digging this crescent shape thing, what you were digging was basically just baked into the model. Like you just booted it up. You didn't need to give it any instruction. It just went and started digging the exact thing it knew how to dig. But once we started getting to real tasks, so digging, trenches with spoil piles in various places, or eventually like the more real tasks we're doing now, and like on an actual construction site, we needed ways to kind of condition the model on like what its goal was, what its task was. So we had to add some new kind of inputs and some new parts of the model to handle those inputs, to kind of think about, and then how do we get that labeled from our data, right? We don't want to employ a bunch of manual labelers on this if we can avoid it. So how do we kind of, from our data, figure out like what the thing was trying to do, and then bake that into a format where the model can now like do that thing with some instruction, so make it more controllable. I'd say that was one big axis, and the other one was just the amount of data. So as you start to want more generalization, like for example, we opened up a second test site where we were doing autonomy, and at the very beginning, things didn't work so well on that test site. But by actually scaling up our data collected from all of our machines, we were actually able to get that same task working without any data from the new site, just with data from the other sites. We were able to get it working. To get it working better, we added some data from that site too. But I think that was where the data started to scale up and where we started to see the first kind of returns on investment from some of the infrastructure we built.
Yeah, a lot of what was happening in the tail end of the first 6 months when there was this heavy iteration on the model is that the infra team went back and started building out scaled data platforms, scaled training platforms, scaled evaluation platforms. And so we kind of knew that the data was going to be the driver. And so we wanted to unlock a lot of early wins, but we also wanted to unlock scaled training at the right time, kind of the same concept that we talked about. And so that also, I think, really came together somewhat perfectly, where now we've got kind of very high scaled training on, petabytes and petabytes of data. But that was not the case in the first 6 months. I think it was somewhat seamless, mostly.
For the most part, yeah.
we did an okay job.
Yeah.
And you managed to keep that fast iteration loop going even as the data scales up?
Yeah, I think the key there is really like how we run the company. It's not technology, it's people. It's really how we kind of started with the thesis that all the different parts of the company have to come together to enable these fast loops. And that means like the people really coming together. That's when we started, in that first offsite with really the people coming together. And we've continued that. We've have kind of very frequent, I would say, meetings between infrastructure, machine learning, and robotics, and hardware, all these different places to kind of actually get that flywheel continuing to go. So yeah, it's not really, technology is the how, it's like how do we actually do it? But the real way that it gets done is people talking and figuring out, well, what do you think you're going to need? What do we think you're going to need? Like, what do we think is going to actually happen, on the infrastructure side that we might not be looking at that we need to invest in? And I think the same is true for every different team as they kind of interlock.
Yeah, and it's kind of like a constant climb, right? Like, of course, I think the ML loop is great and fast, but every week I go to this meeting with Tom's team and tell them how slow and terrible it is. Yeah. And there's a number of ways already, like right in my head, where I'm like, it is fast, but this and this and this need to improve. And so we're never done with that, right? It's always a continual improvement. Yeah. And the idea is you kind of keep those improvements going while you're also scaling up the data. Yep. And then that kind of keeps things running in a sane way where you can still iterate pretty quickly.
I wanted to touch on how we think about safety with this. So now we're doing a real task. We're operating at real sites. How do you manage safety with this end-to-end learning approach and a 100,000-pound robot?
Yeah. Should I take that one? Yeah, sure, I'll start. I would say, so a lot of us work in self-driving. I said I was working on autonomous trucks. I think one of the things we took away from that is we really wanted to set this product and this company up so that the exact outputs of that deep learning model didn't need to be safety validated. And so specifically what I mean by that is, you have something like, Waymo, one of these self-driving car companies, you need to do this massive validation because driving is just this inherently unsafe activity, right? You're on the freeway, you're at 60 miles an hour, right? If somebody messes up a turn signal and you swerve at the wrong spot, there's no way to make that a fully safe system, right? It has to be safe based on the exposure, and you kind of need to do this big evaluation and make this safety case of like, we've ran it on millions of miles and here's what it looks like. That makes it really slow, right? It's kind of the opposite of what we were hoping for with the ML loop, right? It's really slow and hard to deploy. And so what we wanted to do instead was keep our safety system as much as possible kind of separate from the core kind of deep end-to-end learning approach. And so that way, even if that model makes some mistakes, which it will do certainly during development, those mistakes only hurt productivity. They don't hurt safety. And so we have kind of backup, layered safety approach where, for example, they will detect and prevent contacts with objects that we detect kind of separately from the logic, which is deciding kind of inside the ML model how to interact with those objects.
Yes, we really kind of, to paraphrase, tell me if I've got the gist right, we've tried to separate out as much as we could safety into a more traditional problem where like the solutions are more known.
Yeah,
and really lean into that perception, like safety perception and more traditional safety-based system, which we can kind of verify and validate, but it's much smaller in scope than trying to validate a whole behavior model. So like you say, the behavior can't impact safety. It can impact productivity. Safety is kind of its own separate piece that we know is going to work, and therefore it's like the foundation and the guardrails that we can all operate in very, very quickly.
Yeah, and where it makes sense as much as possible, we'll share infrastructure between those two. Like both of those systems need to process images, so we have a lot of shared infrastructure there. Some of the shared architecture on board as well. But the idea was the safety problem, at least especially when you think about like people and vehicles, it's like much simpler than the safety problem on self-driving cars, for example, because you've got these large vehicles, they're close to you, they're slow moving, and the construction site is a controlled access site. So that really changes what you expect to see. You still need to detect things, but a huge percentage of the time it's going to be adults with safety vests on walking around the site, and they kind of know where the excavator is and what it's doing.
Yeah. So your response can be much more kind of black and white, right?
That's
if you
right.
see something you don't like, you can stop. You don't have to continue. You don't have to change lanes. You don't have to do something more complicated. And so like, in that way, we like allow ourselves to get safe quickly and more clearly.
It's not like heartbreaking on a freeway is not the best thing to do.
Yeah, exactly. A huge pain in my previous life was like, constantly thinking you needed to brake and then creating a very bad experience. Yeah.
Cool. So let's talk a bit about the path forward. What gets you excited about this technical approach and how it's going to scale as the company grows? We get better at the tasks we're doing. We add new tasks.
Do you want to talk about from the model side? I can.
Sure. Yeah.
I'm going to put you on the spot.
No, definitely. No, I'm really excited about, I think scaling to doing useful work. That's really, and we're starting to do that now, right? We're starting to do really useful work now. But getting to the point where we're kind of meeting productivity expectations on a real site, on a real task, doing real work, building real infrastructure for the like physical world. To me, that's the exciting application. On the kind of technical side, I think what that really means is data and controllability of the model. So like making it so that real people on a construction site, the foreman has confidence in what the machine's going to do, not just from a safety perspective, but also from the perspective of like, is it going to put the dirt in the wrong place? Like, can I stop it from doing that? Can I control it? And so making it kind of more reliable, more robust, and able to like really meet the needs of a site, I think it requires a lot of data. It will require a lot of ML experiments on how to make the model controllable. And I think it's going to be a lot of fun.
Yeah, and I think adding to that, we are more and more trying to figure out, how do you integrate autonomy into kind of a complex human system? So into construction and into construction projects overall. So figuring out the kind of the application of the human interface side of autonomy is pretty exciting for us, and we know it's like a tough challenge that we're taking on. I also love your answer of like we're going to do productive work. Another thing I'm pretty excited about is that a lot of work in construction is dangerous. It's inherently dangerous, and we have an opportunity to do some of that more dangerous work more safely. And so, of course, I look forward to really having large impact on kind of overall construction, but I also really am excited about making kind of the less safe work more safe by using autonomy instead of humans. So.
Yeah, and just the simple things like, the machine doesn't get tired. It doesn't need to take breaks. It doesn't get tired at the end of a long shift. So it can be more consistent.
Yeah,
and safe.
And it can work on the side of the highway more safely. It can dig a trench without having to have a person climb into it and all this good stuff.
Are there any like cool, interesting behaviors you want to see the machine do? I know we've seen those YouTube videos of excavators doing some really interesting
excavator Olympics style
That's
stuff.
mine.
Like climbing the tower.
I think one day. No.
Standing up a beer bottle.
It's not a goal, but I do love those excavator Olympics like YouTube videos. Those. I think that those operators are like truly expert, and I think that it's pretty. I think indicative of really kind of like the attitude that people have about their work, actually. Not to like draw too big of a thread out of excavator Olympics, but it actually, when you talk to folks who are working on construction sites and working in construction in general, they have a lot of pride in the work that they do. And they have a lot of pride really in the transformation they bring to the country. And I think we have that same kind of pride and want to participate kind of in that same kind of effort that everybody is in. And so we really feel kind of that like broad support and like love the kind of the true expertise that people have.
Yeah, I think that's right. Like this work is taking us to a lot of, states I've never been to, places I've never been. And something that might sound really boring, but is now very exciting to me is like the dirt is different in all of these places, right? Like every state has its own kind of dirt and like different, are you near a riverbed or are you near something else? And right now the model is kind of okay at that, but it doesn't do very well. For example, if the ground is too hard, the model doesn't understand that it needs to like push harder and how to do that physics. So for me, that's a really exciting part of like seeing it, for example, after a rain, it's muddy, then it can dry out, you give it a week and now you have a really hard layer on the top of the dirt. And right now the model struggles with that. And seeing it get to the point where it can kind of implicitly understand like how to push on that dirt and how to do it just right. The excavator actually backs up a little bit into the air and then pushes through the ground. Like that's what the expert humans do. And getting to the point where our model can exhibit that kind of like dirt manipulation at that fine scale is really the thing I'm like most looking forward to.
Yeah, and when we can do that across multiple vehicles, and when we can coordinate multiple vehicles, and where it is not a linearly scaling like effort of complexity to do that, when we can really lean into the infrastructure and the data to kind of help us broaden out the company and the capabilities, I think that's going to be spectacular.
Yeah, like bringing on new things, right? And we actually have already seen a little bit of this, right? Like we were able to add a site not long ago. I mentioned the first test site, but we were able to add another one and switch also machine types, different types of excavators, different sizes. And we were able to see things actually working, a little bit of early signs that things are working without needing to go do a bunch of engineering work specifically for that thing, at least on the autonomy side. And so I think, seeing that like, Tom has a longer horizon than I'm looking right now, but seeing that like machine number 2, like a different type of machine come up and seeing, 80-90% of what we've done just like poured over, right? Because a lot of the ML system, it doesn't know it's an excavator. It doesn't really have any of that stuff hard coded in. It just knows like, this is my state space, this is my action space, and here's my data. And then we do a lot of work offline to kind of make sure it pays attention to the right parts of the data, make sure it gets the right losses and all of that. But the overall kind of like underlying architecture is agnostic to all of that. And so hopefully that will let us continue to scale to kind of new tasks and new challenges. Yeah.
And the hope is that all this behavior is just emergent, right? As you add more data, you don't need to keep hard coding all these different maneuvers, and what you add a new maneuver and all the old ones break because they aren't like tuned for this one.
Yeah, that's right.
That's right. We don't need to do that hard coding.
I mean, we in our autonomy today, we have no hard coded behaviors, right? Zero. The entire planner is like 300 lines of code that just loads the model and spits out the trajectories. Now, what we do is if we are struggling in a certain thing, like I mentioned, the hard dirt, we will go and pay attention to that from a data mining perspective. So we might write a bunch of code for it, but that code will be like, find me more examples where the dirt was hard and make sure those are getting into the model. Or we might do something like add a little probe to the model inside the architecture that lets us kind of understand what it's doing when it sees hard dirt. So we might do things like that, but then at the end of the day, those things are all kind of out of the onboard system, right? So you don't have all that complexity of thousands of if statements that kind of builds up over time, because that's just in the kind of offboard like data processing layer.
So to close out, is there any advice that you'd like to give to new engineers that might be trying this approach for robotics, either on the training side, on the infrastructure side?
Why don't you go first, Noel?
Sure. Yeah, I would say don't steer away from trying end to end. If anything, I actually think our ends should have been even further than they were when we started. Right?
We've expanded them.
We have expanded them. Yeah. And so far, I've never regretted them being like
great.
too expanded. It's been the other direction. That being said, that does mean you need to kind of bone up a little bit on machine learning. You don't actually, these days, with what's available in open source and papers and stuff like that, if you can kind of read a paper and implement parts of it, you don't actually need to be like a brilliant ML modeler. Like you can actually get a lot of that stuff, talk to a couple of people, and you can actually kind of quick start with a lot of that stuff without really going super deep into the weeds for the first few months at least. So I would say like don't be too afraid of it if you haven't done it before, and give it a try and see how it goes.
Yeah, I think for infrastructure, the technical advice I think is focus on the data first, and then scale on top of that, scale compute on top of that, but make sure that you have a good understanding of how people are going to use the data, and then you enable that in ways that that you'll eventually be able to scale out. And so that's kind of the easy one. I think the harder problem and is really it's the people. So if you're going to try to do something as, I would say, like as deep stack as robotics, where you're going all the way from the hardware all the way through stuff that's running on board, things that are running and being trained in the cloud and the cloud infrastructure of applications, you have to figure out how to bring together lots of different engineers, lots of different people who are not engineers, and really try to understand like the problem space, the product space, the engineering space at the same time. And so you can't ignore kind of that holistic, like bring the people together, bring the customers kind of into your worldview. The technical problems themselves won't, I think, ultimately get to the product problem. There's so many technical challenges that you have to have a really good way of kind of charting a course through to the actual product impact. And that is really just by bringing people together and working together.
Yeah, I guess one thing I'd add is build the flywheel. And what I mean by that is like make it as easy as possible to do experiments, especially when it comes to ML. Like you're not going to get it right the first time. Make it so you can try one thing, try another thing as quickly as possible and as safely as possible if that's relevant for your space. And even if the inside of the model is a black box, still I think a lot of kind of good engineering systems thinking can help you, right? Think about the inputs, the outputs, the time scales, right? The data you have, what's in that data, go study that. And if you do that, you can really, it's like data is like 10x, then maybe a tenth of that is loss function and a tenth of that is model architecture. So you can really get quite far without needing to be like a deep expert in ML. And then like once you have a nice demo, you can hire some people one or two people that are those experts if you need them.
Awesome. Well, thank you both for taking the time to chat today and sharing more details on our approach and where we go from here. Hope it was enjoyable.
Thanks, Rushil.
Yeah, it was great. Thank you.